Hello and greetings to Sir Safirin. And this is our assignment for telecommunication switching with code number BRT 3393. And this is we are from 4BRT S22. So this is our table of content. We have 8 important table of content. The first is meet our team, where we introduce our teammates. And the second is our introduction. The third is our objective, what we want to achieve by doing this assignment. The fourth is the task one, technical design and financial analysis. The fifth is simulation using Cisco Packet Tracer. And the sixth is the simulation for the demo for the packet tracer. And the seventh is our discussion, what we find, and then the eighth is our conclusion. So here is our team member. We have Magat Mama Irfan with batting card number B0822102120, and we have Mama Hashim with batting card number B0822102205, and we have Google Analaki Kanigasalan with batting card number B0822102204, and Natarenda Najas Bai with batting card number B0822101001. And this is our introduction for what we have is local exchange. We can divide by four, which is our function, our application, our features, and what geographically. So the function is that we can understand is that is it can be used as code switching, and it can be used by as network traffic management. And the application for local exchange is that we can use it by traditional telephony, or we can use it as modern IP based network. So why it's very good? So its feature have very good scalability. It can be flexible, and it can be reliable. So the reliability, and the geographical advantage is that it can operate with a specific geographical area, and it can use as a subscriber interconnection, which can be used in long distance. So our objective is that uh, is to design and analyzing costs and simulate a local exchange to support 1,000 users. So next, I will pass to my team member.
Thank you so much, Nathan, for passing the presentation to me. So, my name is Gugan Analaki Kanikasaran, metric card number B0822102204. So, today in this assignment, I'm going to explain about technical design and financial analysis. So, let's get into it. So, first thing, the procedure, which first we need to determine the required equipment, switching system, line cards, trunk interfaces, signaling, power, OSS, transmission infrastructure. And secondly, we need to specify quantities and technical specification based on the thousands users requirement. Thirdly, we need to develop a network architecture diagram. Fourth, we need to conduct a financial analysis, including cost estimates for equipment, software installation, and maintenance. Fifth, we need to develop a budget breakdown and a total cost estimation. Sixth, explore potential vendors and service providers. Last but not least, we need to consider scalability and future expansion. For the first technical design, this is our diagram, technical design we did for our assignment. So this is a hybrid and topology. Combine star and ring configurations to ensure scalability, fault tolerance, and efficient performance. Star topologies simplify device management within clusters, while the ring topology interconnects these clusters, providing redundancy and smooth traffic flow. The network features 21 switches, 4 routers, 4 Cisco UCS servers, and supports 1000 IP phones for seamless VoIP services. This design enables centralized management, robust connectivity, and high efficiency, making it well suited for modern and future networking needs. So for the next part, we have a budget breakdown, which is also the part of financial analysis. As you can see this table, we have listed every component and how much quantity do we need them, and also per unit per price, which is their value. So as you can see in this example, we have this table, central switch one quantity is 67,500 ringgit, and total cost is that. And if you see in line cards, we need 20 units for this project. So we put 20 in quantity, and per unit is 4,500 ringgit, which gives us the value of 90,000. So you can see this is the total equipment cost, 378k, total installation cost under 1250k, and also total annual maintenance cost 51,300 ringgit, which is the total cost of breakdown for network includes equipment installation and maintenance. Equipment cost amount to MYR Malaysian ringgit 370k, covering components like switches, line cards, UPS, or access software. Installation costs are about 101 ringgit to 250, including labor and constellation. Annual maintenance cost total 51 ringgit, 51k 300 ringgit, which include routine maintenance and software updates. This comprehensive budget ensures reliable operation and future scalability of the network. So thank you very much. Next, I will pass to Muhammad Hashim.
Hi and good day to our IR Safirin. Now I want to explain about the simulation using Cisco Packet Tracer. So, before that, we need to know the procedure. So, each of project, we need to know the procedure to set up any local exchange or any designing for Packet Tracer. So, first of all, we need to set up the simulated local exchange. So here, set up the simulated local exchange environment based on the technical designs. So technical design is our designing based on our users that needs to put on the each PC and on each IP telephone. So secondly, we will configure the components, which is switches, routers, and telephony device. The three components is used based on our financial analysis and our how many we want to use it. So this all components to mimic a local exchange. The third part is the implement protocols and signaling for call setup, routing, and management. So next one, we need to test the simulated exchange by placing calls between the simulated subscribers and external network if applicable. So the fifth, we need to demonstrate integration of voice and data services if applicable too. The sixth one, document the simulation process, including screenshot, configuration, and challenges. For the part six, we need to know the results and outcome from our assignments. For the seventh, we analyze the performance and behavior under the different scenarios or load the condition. We need to suggest potential improvement or enhancements. Okay. So next, this is our Cisco diagram. So which is we using the each exchange we have two IP phones and two PCs. So here we know that we need to use some additional PCs and additional iPhones for 1,000 users. For we need to demonstrate some some demo by using the two PCs and two phone only, because we need to know the process how it can be successful to communicate each of sections. So that we not need to use the 1,000 users. But if we want to use the 1,000 users, we can configure the DHCP at the PCs and the iPhone too. Okay. So here the server one server. This is the main server to configure the DHCP pool between the four router. Okay. Next, we go into our simulations. So hi and good day to the two Safirin. My name is Muhammad Hashim bin Muhammad Rafi. Matrix number is P0822102005. Today I will be explaining more about the simulation. So I have gone a mistake for this recording, because this recording is need to come in part two, but I have some mistake from the part 2 video because I forget to put some results to show you that the PCs can communicate each other. So let's uh, let's towards it. So we pick some section for uh, for example, this is the first department, this is the second department, and this is the third, fourth department. So we have the four department. So each department we have a switch, we have IP phone and PC. But we can whenever we can add the IP phone and add the PCs to increase the users. But you need to configure the router and switch first. But in this case, we need to demonstrate with the small sections. I mean the small scope. So if we can put the monitor more, but I will explain how it's work. Okay, then we can use the more users. Okay, so in this PC, I need to show the ping. So here are the 100.67. So from this section, can we ping from this? Okay, let's see. 192.168 point what? 167. Okay, it should be successful. It should be successful, but request time out. Oh, yes. Yeah, it has a communication between the two departments. So we check for the other departments. Something here. So the IP address is 134. So we try 134. It should be perfect. Yes, it's perfect. It's replying to the 134. So the last department is the up this stuff here. So the IP address is 100.98. Okay, 100.98. Okay, we open again. And 100 and then what? I forget it. 198. 198. Okay, it should be successful. Oh, request timeout. Okay, it's successful to communicate to each department. So yeah, the 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 ping of each computer is not a problem. So we have configured we have configured the OSPF and the DHCP to give a communication the PCs to other department. Okay, so we jumping into the part 2. Hi and good day to hi, guten tag. Today I want to present about the simulation that given task to our group. So here is simulations. Okay. Firstly, we need to ping the PC, and we need to check the the, the phone. Is it the phone is can call the each section. So if you click this phone, and then we have some numbers here, 1002, and each of section we have registered the number. For example, here we have 2002. So here we have 3002, and we have here 4001. So what we configure that we change the dot 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 2 dot 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 3 dot 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 4 and dot 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 1. Okay, we can't use the same number for our simulation because of we need to differently number to access the phone number, because it will be stack the phone number. Okay. So first of all, we call the other phones, which is here, and the phone's number is 2002. So here we can call 2002. So here ring out. We check it on the 202 phone number. So here, as we can see, the phone is ringing from the phones here, 1001. So we need to take it out, and it's connected successfully between the 1001 and 2002. Okay. Okay. Let's recall the uh, 3002 line number. So from here, 3002. Okay, we call it. It will ring up, and here should be, yes, it should be ringing and connected to both of phones sections. Okay, so we test it to mistake 4002. Okay, we call it 4002. It should be ringing up, and here the phone is ringing. So we pick it, and it's successfully connected. So here, what we can see is the phone the phone between the router can be connected, not directly, but we're using the DHCP. Okay. So the data VLAN. So here we use where here. So I could declare it first. The data VLAN is we use the 0.10, and the voice VLAN is 0.100 for the voice VLAN. So the voice VLAN is the same for all router, but the data VLAN is not the same. It will change. So here the switch mode is strong between the router and to the switch. For the router to the PC, it's called the switch mode access. So as we can see here, this is the DHCP. We have configured 4 pool. Why we need to configure is we need having a IP on the end of the device. So for example, we need to know the IP address. We need to put some IP address to the PCs or the phone. We need some DHCP pool to configure it to get the end device to get its IP. Okay. So for the next telephone service, we configure the telephone services on each router. So to get the number for each. So the telephone service, the functional telephone service is to give a number each of IP phone. Okay. So we have been configure the peer-to-peer configuration from router to router. Okay. As we can see here, we have installed some peer-to-peer configuration, and we also have OSPF routing. The function OSPF routing is the cross-platform. Okay, it's the cross-platform where the router is go. If you ask me, the function is where the router is go, because we can't reach the phone to this part without an OSPF. So we need to configure the OSPF routing to this phone call to the other department. Okay. So I hope this will clear the explanations. Sorry for my word and my explanation is too bad. So yeah, next I will pass to next session. Thank you.
Hello, my name is Megat Muhammad Irfan. My number metric is B0822122120. I will continue on discussion part. The discussion highlights the system technical excellence, cost efficiency, and reliability, emphasizing its ability to handle both voice and data traffic securely through VLAN segmentation while remaining scalable and adaptable to future demands. Its modular design ensure easy upgrades and financial planning prioritize affordability and sustainability through vendor agreements and free licensing. Simulation validate its performance under heavy traffic, and redundancy enhance reliability by preventing service disruption. Seamless integration of the services, phased implementation, and comprehensive training ensure smooth deployment, effective operation, and long-term success in addressing current and future telecommunication needs. So I will talk about conclusion. In conclusion, the proposed local exchange system design has been cautiously evaluated regarding its practicability, efficiency, and cost effectiveness for contemporary telecommunication needs. Since the system can reliability support up to 1000 users or more, it will ensure that there is minimal or no more than the expected interruption and consistently high performance under different traffic loads. This simulation confirms that it will seamlessly manage both voice and data services while continuing to be efficient in operation. The proposed system is therefore ready to be tackled in regard to addressing the key issue of scalability, cost control, and integration so that it can meet the dynamic requirement inherent within today's telecommunication landscape. Its detailed design and financial plan grant feasibility, adaptability, and sustainability for long-term use. That's all from us. Thank you.